Imagine standing in a vast, wind-swept valley. Look around you. Every single human being alive on Earth today is standing in this field. Not your city, not your country, not even a mid-sized college stadium. The entire human species, every thinker, builder, child, and elder, fits into a group of roughly 1,280 people. The ground beneath your feet is frozen and cracked. The air is dry and thin. A single brutal winter, one extended drought, or one contagious fever sweeping through camp is all it takes to erase humanity forever. The story of mankind ends here, before it ever really begins. Here is the chilling truth. We almost did not make it. And the proof of our near extinction is written directly inside the cells of your body right now. Most of us grew up with a very specific story of human origins. You have probably seen the famous illustration in biology textbooks. An ape, slowly standing upright, morphing into a hunter, then a farmer, and finally, an astronaut. It paints evolution as a clean, victorious march upward. Humans appeared in Africa, got smarter, tamed fire, crafted sharper stone tools, and steadily spread across the globe wave after wave. It is a comforting narrative. It makes our dominance over the planet feel inevitable. For a long time, scientists accepted this gradual rise as fact. But when modern geneticists started looking past fossilized bones and began reading our actual genetic code, that textbook story completely fell apart. Place human DNA side by side with any other primate, and something looks deeply wrong. If you take two wild chimpanzees living in neighboring patches of forest in West Africa, they carry more genetic difference between them than two humans chosen at random from opposite sides of the Earth. A person in New York and a person in Tokyo are practically genetic twins compared to two chimps sharing the same jungle. Out of every great ape species alive on the planet today, gorillas, orangutans, chimpanzees, we are by far the least genetically diverse. Think about how strange that is. We are a global species numbering over 8 billion people, occupying every continent, living in every climate from the Arctic tundra to the Arabian desert. A species that supposedly expanded unbothered for millions of years should be bursting with genetic variation. Yet, genetically speaking, humanity looks like a population that was cloned from a tiny handful of survivors. Why? What could possibly erase the genetic diversity of an entire species? In 2023, an international team of geneticists solved the mystery by building a revolutionary computational tool called FitCoal. FitCoal works like a genomic time machine. It reads backward through the DNA of over 3,000 modern humans, analyzing subtle patterns of genetic mutations like counting the microscopic growth rings inside an ancient tree trunk. By measuring how genetic variations accumulate over time, the algorithm can calculate exactly how large our ancestral population was at any given moment in prehistory. And buried nearly 1 million years in the past, the data revealed a massive, terrifying scar, somewhere between 930,000 and 813,000 years ago. Our ancestral population did not just dip, it collapsed. A thriving population of roughly 100,000 homins plummeted by over 98%, shrinking down to about 1,280 breeding adults. Let that number sink in. 1,280 people capable of having children. That is smaller than the student body of an average high school. And this was not a temporary crisis. It was not one bad winter or a 5-year drought. This near-extinction event lasted for 117,000 years. Try to imagine what life was like during those 117,000 years. That is, roughly 4,000 generations of humans living permanently on the absolute edge of annihilation. This period coincided with a dramatic shift in Earth's climate, known as the mid-Pleistocene transition. The global climate became colder, harsher, and wildly unpredictable. In Africa, vast green landscapes transformed into relentless dusty deserts. Great rivers dried into trickles of mud. The massive herds of game our ancestors hunted began to vanish, wandering off into distant territories or dying out entirely. Imagine waking up in a small, isolated band of 20 or 30 people. Every single morning is a gamble with death. You walk for 12 hours under a blistering sun just to track a single animal, only to return to camp empty-handed. Picture shelter at night. The wind howls outside, biting into cold skin. Inside, the fire flickers weakly over damp earth and cold ash. There is not enough food to feed everyone, and someone has to quietly decide who eats tonight and who goes hungry. You scrape gray, slick marrow out of a bone that was already picked clean yesterday. In the darkness, a child begins to cough. And nobody knows if that cough is just dry dust or the beginning of an illness that will wipe out half your group by morning. That was not an anomaly. That was everyday life for 4,000 generations in a row. Every single one of your direct ancestors lived through this endless nightmare. If just one of them had been caught by a predator, lost in a blizzard, or succumbed to disease before having a child, your family line would have snapped forever. You would not be here. But somehow, against all astronomical odds, those 1,200 people held on. Here's where the story takes a fascinating scientific twist. That brutal stretch of time did not just test human endurance, it literally reshaped our biology. Look at every other great ape. Chimpanzees, gorillas, and orangutans all have 24 pairs of chromosomes. Humans only have 23 pairs. Somewhere in our evolutionary past, 2 entire chromosomes were fused together, end to end, like 2 pieces of shoelace tied into a single long strand. That fused structure sits inside every cell of your body right now. Science calls it chromosome 2. For a long time, geneticists wondered when and how this fusion happened. Recent genetic analysis suggests that this exact fusion event occurred right around the time of the massive population bottleneck. When a population drops down to a tiny, isolated group of 1,200 people, rare genetic mutations that would normally disappear in a large population can suddenly spread rapidly. Scientists suspect that chromosome 2 fused inside one individual during this crisis. Because the group was so small and closely knit, that new chromosomal arrangement was passed down until it became the standard blueprint for the entire surviving population. In other words, the bottleneck was not just a crisis, it was an evolutionary forge. This microscopic catastrophe may have been the exact moment a new branch split off from the evolutionary tree. The shared ancestor of modern humans, Neanderthals and Denisovans, all trace their lineage back to this precise window. The crisis forced a sudden leap in evolution. We are not just the survivors of that near extinction, we are the direct product of it. Without that near collapse, the unique species we call Homo sapiens might never have existed. The legacy of those 1,200 survivors is everywhere around us today. It explains why an organ donor or bone marrow match between 2 complete strangers on opposite sides of the world can actually work. In wild chimpanzees, finding a matching tissue sample between troops is nearly impossible due to their vast genetic diversity. But because all 8 billion of us bottlenecked through a tiny family of survivors, we are all extraordinarily close relatives under the skin. Yet, as mind-blowing as this theory is, science thrives on debate, and not every researcher agrees on how close we actually came to the brink. Some geneticists argue that a breeding population of 1,200 adults does not mean there were only 1,200 total humans alive. Children, elderly individuals, and isolated groups that did not leave long-term genetic lineages may have existed elsewhere on the continent. Other scientists point to the fossil record. During this supposed extinction window, ancient hominin fossils have been found in parts of Europe and Asia, suggesting that some human populations were still moving around and surviving outside of Africa. The disagreement among experts is not about whether something massive happened to our species during this time. The genetic data is far too clear to ignore. The real debate is whether humanity was truly standing on a cliff edge, or if our population was simply fractured into small, isolated pockets across a tough landscape. Whether the total count was 1,200 people or a few thousand, the reality remains awe-inspiring. For over 100,000 years, the entire future of human art, music, science, love, and civilization hung by a thread thinner than a spider's web. They did not know what electricity was. They did not know what a planet was. They had no idea that almost 1 million years later, 8 billion of their descendants would fill every corner of the earth, looking back at their footprints in the dust. They simply refused to give up. They kept finding water in dry riverbeds, kept protecting their children through endless winters, and kept the fire burning in the dark. We don't know their names. We will never see their faces. But every breath you take, every thought you think, and every heartbeat in your chest is the victory they fought for. If you want to dive deeper into how early humans survived the brutal ice age using nothing but stone tools and fire, hit that subscribe button right now so you don't lose this channel in your feed, because our story is only getting started.